Okay, so, I mean, if it's okay with everyone, I'd like to sort of just set the scene more generally for Docker in production, and then talk about the problems with, just very quickly, and then talk about the problems with stateful containers in particular. And yeah, so just super quickly, like, I think that there are like, sorry, that wasn't the presentation. I'm not going to go that quickly. So in my mind, there are like these 4 big problems for running Docker in production. The first one is composition, the fact that you need to be able to have your apps consist of multiple containers that are connected in some way. And like Fig is very popular for dealing with this, and Kubernetes has its own way of doing it with pods and so on, but generally that's becoming a solved problem. Scheduling, you need to be able to like have those multi-container apps deployed onto multiple machines. And then networking, those containers when they're running on different machines need to be able to talk to each other. And storage, you need to be able to have stateful containers as well as stateless containers in your app. Because, and so maybe this is a contentious point, but my view is that you should be able to deploy your entire application. Like, actually, if you go back, there's like, in my mind, modern applications consist of lots of different pieces. Like, you've got some stateless stuff on the right-hand side of this diagram that can scale out, and that's great. But you also have stateful applications, or stateful components as parts of your microservices. And more with microservices, people are putting those stateful pieces into there, and then wanting to be able to have this Fig file that describes their app, deploy that on their laptop, but then deploy the same artifact in production so that they can get dev prod parity. So I guess that's my take. And at the moment, we can only capture the right-hand side of this, but it would be really great to be able to deploy the whole thing. So anyway, I guess, yeah?
What is the problem with just having a dev and a prod that are sort of, all on VMs, not in containers, that are sort of continuously synced for configuration? What do you gain by absolute Docker?
So, how would you continuously sync?
Say Animal or Chef.
Okay, yeah.
And then some kind of database to sync if you want certain parts of the database to be the same.
Well, you can do it that way. That might be fine for some people. I think that the benefit of containerizing everything is that you get to use the same tools consistently, and you don't have to be you don't necessarily have to become experts in managing every single data service in its own special way to be able to deploy it and then manage it at least to a basic level. That's my take. So anyway, enough slides. Like, you don't like slides here. Shall I can talk a little bit about Flocker and the way that we're trying to solve this, or do we want to talk more about like why stateful containers?
I'm clear about it. So what storage? You're referencing state when you're talking about it.
Yeah.
State exists in memory. State exists in disk. There's also just a fundamental data issue that Docker is not particularly good at, which is maybe there are requirements, maybe there are data dependencies that I have with my application that change over time. How do I deal with what does migration actually mean in terms of that? We just need to really architect applications when we're building out containers to address that problem. I'd like to know what context of your points.
Yeah. So while I think that it's great that people are changing the way that they architect applications so that they have this strict separation between a stateless tier and a stateful tier, I think the stateless tier is still there. I mean, the stateful tier is still there, the data tier is still there. I think it's beneficial. I think sort of my view of the future is one where you have one system to manage the entire app, and you can deploy to that system and use it in a consistent way. You also touched on like what does migration mean? I'll talk about so I think there are sort of 3 possible tiers of migration. So there are operational reasons. So I think Docker's been really successful amongst developers, and that's great, but it's led to the tools being built for a single machine. But if you once you go into production with this stuff, you have a different set of concerns. You have production concerns, and one of the production concerns is often, well, ops people want to be able to move things around. They want to be able to move things around because their machine is getting overloaded, or because they need to like upgrade the memory, and so on and so on. So it's useful. It was useful for VMs in the VMware days, to be able to move your VMs around. I think you get similar operational benefits from being able to move your containers around. So does that help? I think in terms of that migration, if you agree that like it's useful to be able to move things around, then there are 3 layers. I think the first layer is what Flocker does today, which is to take a snapshot of your volume as it is now while the container is running, replicate that over to another machine, and then shut down the container, take another snapshot, and replicate only the differences between the first snapshot and the next to reduce the amount of downtime. So it's proportional only to the amount of data that's changed on disk between one snapshot and the next, and then start the container up on the other side, and then reroute whatever network layer there is, such that, or update your service discovery, such that your node comes back up, or your database comes back up. That involves some downtime. That's sort of level 0, I think. Level 1 is that you can manipulate the network layer so that you can pause requests, and you can get that downtime down as low as possible. And because you can pause requests in the network layer, you can make it seamless from the user's point of view. You can only use some latency to run from downtime. And then level 2, the third layer, 0 index, is that you might want to copy memory around, basically. And this is the Cryo project, which looks interesting for that. But actually migrating memory and open TCP connections is still a bit of a dark art, and that's quite far away. Does that help?
Yeah, when you say snapshot, is that a non-destructive snapshot mechanism? We do support a lot of computational science, right? So it's just a duplicate. They've known it with traffic sitting there turning canned algorithms. Right? So the data really matters, the code really matters, but the state the code is running is critical, right? Because we'd like to be able to snapshot code as part of like a server failure, you run at scale, 100,000 people, right? So if one of them fails, we have hardware that's going to catch that state, snapshot it before it goes down so that it comes back up. You have at least the memory blocks you can reconstruct. So is that the kind of snapshotting you're referring to?
So would your use case suffer if, so is your use case then, are you able to sync turn the process and then start it up again and have it come up from the state that it had on disk?
Oh, we don't want to sync turn, right? So these processes are already running.
Yeah.
So we want to be able to like physically pause execution of stop the cycle.
Yeah.
Snapshot memory, snapshot disk, move those, go.
So it sounds like for your use case, you need the most advanced form of migration that I described, and we don't have that yet. But I think we'll get there. And I think at that point, containers will be viable for that. Although even then, you talked about failure, and so doing failover and keeping the process running, that's really hard. I think VMware tried to do that with their so vMotion is for controlled migrations, but this was
It's all shut down if you have a failure.
Sorry?
there's a failure, HA actually kills the box and spins it up somewhere else.
Yeah. So it's not HA, it's the other one.
It's like you replicated it.
Yeah,
What are you talking about?
replicated everything. That didn't work for multi-core processors. So, I don't know, I don't think we're going to get there. That's probably beyond. I think that the application needs to be architected such that it can tolerate some failure and assume that it will get brought up again. Ideally with the latest version of the data handle disk. But I think the application is going to have to deal with that for a long time. That's my take.
So in a lot of earlier sessions, people have said that Docker containers in general are kind of not the best use case for write-heavy disk I/O workloads, which what's all that goes to database on Docker. You're saying that you guys have is that something you would actually consider is having databases in a container?
So I strongly disagree with that. Like as a premise, I think that containers are great for write-heavy workloads, especially if you run them on bare metal. And if you look at most of the databases and service companies use containers because they're much better at heavy I/O than VMs. That's actually one of the places where VMs suffer the most in terms of performance is write-heavy workloads. But the reason that people aren't wrong, the reason that running databases in Docker is a bad idea now, at the moment, with the current state of the art, is because Docker's volume management doesn't work well across multiple machines. The fundamental problem with volumes in Docker today is that Docker best practices say that you should when you want to run a stateful container when you want to run a database in a container, basically, or any stateful application, Docker says, oh, you should use a volume. You should bind mount a volume from outside the container into the container. The huge problem with that is that if you've got production, if you've got multiple hosts, then you want to be able to tolerate failure, you want to be able to move things around. So you want your machines to be cattle, not pets, right? But as soon as you attach like a volume on a host inside a container, that container then gets stuck there. So that's the problem. And that's the problem that we're trying to solve with Flocker. And the way that we're trying to do that is to sort of abstract the volumes away from the specific machines that they're on. And we've got a couple of different backends, a couple of different ways of doing that. The first one is the ZFS backend, which uses the snapshot and replicate mechanism. And that's available today. Like you can use that today. And the one that we're working on at the moment is an OpenStack backend, so that if you are running on top of OpenStack, then you can just allocate a block device from Cinder to each stateful container, and then moving that from one VM to another is actually quite easy. That just means detach it from one VM and attach it to another one. And in principle, it's actually possible to use that on bare metal as well, which is kind of crazy, but possible.
AWS, same thing.
And yeah, EBS is we're going to have an EBS backend as well, a GCE backend. Yeah.
Good. Network resilient, distributed mounted file system available. So I can do like so if I'm launching multiple hosts, I have an NSF mount to my machines by default or automatically working when it goes crazy.
So we don't have a sort of magic file system that does that yet. But if you're on like AWS or if you're on Google Compute, you already have underlying block storage. If you're on OpenStack, you can plug it into Ceph, or you can plug it into a SAM if you have one of those or if you want one. So the idea with Flocker at the moment is there's sort of like the container universe and all the container orchestration systems, and there's the storage universe and all the different storage backends and storage providers, and we're just trying to join the two to make it possible to run your stateful containers on your storage to begin with, and have the volume, the storage actually follow the containers around as they get rescheduled by the orchestration frameworks. So that's our sort of phase one. But we also have this the ZFS backend, which can do what we call peer-to-peer volume routing. So if you are just running on bare metal with local disks, or you're using VMs on your laptop, then you can use the ZFS backend to migrate things. But the ZFS backend currently doesn't do failover, so you can't automatically recover because it doesn't do its own synchronous replication. And that's a hard problem to solve. But Ceph does that, for example. So if you plug it into Ceph via the OpenStack backend, which will be coming soon, then you can get those sort of features. Does that make sense?
So the value of that approach versus having a sidekick data container that's running the fuse mount configuration objective for each of the cloud storage providers is
So
would be abstract from how you want it. If you had a backend like ClusterHQ, you could say that one backend provider Blocker, and Blocker simply actually make EPS for it. And so if you as an implementer service just say, I want to volume, I want 10 gigabytes, and the backend has implement that for you. So that doesn't become part of your specification here. You can just provide the specification of what you want in the backend and figures out basically what's available, what's going to be.
that's right. So if it's okay with everyone, I'll just talk for a little while about sort of the journey we've been on and where we've ended up. So in August last year, we launched sort of our 0.1 of Flocker, and what Flocker is it comes in two pieces, like this, like these pictures. There's a Flocker deploy command you run on your laptop, and that takes two files. It takes a fig file, which describes an application. There's a set of connected containers with links and volumes, and it takes a deployment manifest, which just statically maps hosts in your cluster onto the containers. So this was like a very, very early sort of demonstration that you can have a multi-host setup that has state. And then the one feature that Flocker 0.1 had was that you could change the deployment manifest to say, actually I want to run this container on a different machine, and rerun Flocker deploy, and it would move that container there, and the links would carry on working, and the volumes would be in place. And so you could use this Flocker deploy command to deploy onto like this cluster. This is meant to be like 4 different machines with some Flocker containers on it. Anyway, so the fig YAML, I mean, the super simple example is actually from the fig website. It's just this Flask application and a Redis server, and you can set up some links and you can set up some ports, but specifically you can set up volume, and then you can have these two versions, and so that's the data volume for Redis, and then specifically you can have these deployment for node 1 says like, oh, my first node should have both of the containers on it, and then the second, and then you can deploy that, and it loads it up and it works. And then the second deployment just moves the Redis container onto the second machine. So you can rerun Flocker deploy, and it does this two-phase push that I described, where it takes a snapshot, it copies the data over, it shuts down the container, it takes another snapshot, and replicates that, and starts the container on the other side. So in that way, we were able to say, well, for small clusters where you want to manually manage placement, you can use this to just manually deploy things, but it doesn't work like, it was very limited because it didn't work for multiple users that wanted to interact with the clusters simultaneously. There wasn't an API, and so on. And so since then we've been busy, we've built an API, we've now got an architecture where you have API server, and you have a set of container nodes, and they talk to the API, and the user can talk to the API, so you can now do multi-tenancy. But the huge problem here was this. It was that we ended up having to wrap Docker. So we ended up like writing this Flocker deploy thing that had built into it a fig parser. And we didn't want to be in the business of like doing orchestration. We don't want to be in the business of all this. We just want to solve data problems. And so we ended up going down this route of looking into Docker extensions and actually pushing forward the Docker extensions project. And so I won't talk too much about extensions, but the general idea is, we came up with this project called PowerScript that some people may have heard of. In fact, who's heard of PowerScript? Anyone? Okay, yeah. All right. Okay. So, yeah.
So the volume condition that you showed in the previous slide,
Yeah.
is that the host volume that you mounted for the container, or is it the volume that comes inside the table?
So it's the host volume. It's actually allocated on a ZFS pool that exists on the machine, and both machines have a local ZFS pool, and so you just define it like using the fig file here, and Flocker manages creating the ZFS file system out of the pool, and then doing a snapshotting and replication to move it around. Yeah, so any other questions on this sort of basic Flocker stuff?
I think the answer is ZFS, but I want to ask, what about pseudo file systems like HDFS or Oracle table spaces? Is that, if you're managing those with Flocker, are those just going to live in the ZFS pool?
Yeah.
Okay. Thanks.
So the way that the layer at which we've decided to attack this problem is the file system level. So we're not, we didn't want to become experts in every single database in the world and leave that to the people who are actually running the stuff. But we think it's valuable to be able to provide this basic sort of abstraction level for volumes, and then whatever's in the container is a black box, and you can bring your own container, of course. Like that's the whole point. So yeah, any other questions on that?
That was missing.
Okay. So anyway, we were like, okay, this is fine, but we don't want to have to like compete with Mesosphere and Kubernetes and Docker Swarm and so on. We don't want to end up like building these bin packing algorithms and stuff just to make this Flocker deploy thing work. So we ended up down the road of like, well, how can we have these plugins that can plug into Docker? How can we make Flocker into a Docker extension, basically? And the answer is Flocker doesn't have an extensions mechanism yet. So we prototyped one, and the prototype extension mechanism for Docker is called PowerScript. And what PowerScript is just a way of, so it's an API proxy that sits in between the Docker client and the Docker daemon. And it pretends to be the Docker daemon, but it actually, I can show you. So this is what it looks like basically. PowerScript sits in between the Docker server and the Docker client. The Docker client might be just you typing Docker run, or it might be Docker Swarm, or it might be Mesosphere or whatever. But anyway, so the Docker client speaks to PowerScript. PowerScript can run a bunch of prehooks on any of the API requests, and then one of those prehooks could be to Flocker. And so we managed to prototype Flocker working together with Weave, which is the container overlay network. And that was nice because it meant that we managed to get away from like having to own the user experience. We got away from having to own the command line interface, because we really want our stuff to run with whatever anyone's doing, with Docker run or with like Mesosphere or Swarm or anything. And also this approach means that we can integrate more easily into things like Stack Engine. So anyway, so PowerScript then got us to the point where, okay, we can prototype these Docker extensions. We're now working closely with Docker themselves to actually get Docker extensions into the official Docker core, and that's a work in progress. But when that happens, it will be possible to type Docker plugin load Flocker on each of your Docker hosts, and it will pull down a container that is an extension. And we're going to ship all of the extensions out of themselves as containers. So that's sort of where we're going with this. So I can show you a short demo, and the demo is basically to show how when you've plugged Flocker into the Docker daemon. Rather than having to use the Flocker command line, you can use the regular Docker tools, but that it adds capabilities to Docker around these portable volumes. So, I'll show you here. So I've got a couple of machines. Might actually make more sense if I do that. So I've got a couple of machines here that I span up just a few minutes ago, and let's see, node 2 is on the bottom, node 1 is on the top, and let's see. So what I'm going to do is I'm just going to run a container on node 1, and let me just take you through what's happening here. I'm just doing a regular Docker run command, and this is an unmodified version. This is an unmodified version of Docker CLI. This is just regular Docker 1.5. And what's happening is we're just bi-mounting what looks like a perfectly regular volume in here, except the volume starts with /Flocker. And so PowerScript adapter, PowerScript Flocker adapter that's plugged into PowerScript, which remember is the prototype of the Docker extensions mechanism, intercepts the request, and before it passes the request through to the Docker daemon, it gives Flocker the chance to create a new ZFS file system for that volume to live in, and then it'll spawn a container like regular Docker run stuff, and it will echo hello Austin into the file in /data. So I can hit enter, and that happened really quickly. But you can now see that we've actually got a new ZFS file system. There are two of them because I created one earlier. But if we look inside, let's see. If we look inside that file system.
What is the delay on these minutes?
That's just because AWS is terrible. I think it's because the EBS volumes haven't pulled up or something. But yeah, the file is there. Cat file on this machine, and so you can see that the container put the words in there. Oh, that's a different volume actually. So that's got hello Austin in it. That's nothing special so far. That's just a local volume on the machine. What's kind of cool though is that we can, on a different physical machine, this is a different VM. See, the IP address is different. We can run a different container. Let me just check. Yeah, so on here we ran Docker run with /Flocker/test3. And if we run a different container on here, on a different machine, referencing the same volume name, and try and cat that file, then it cats hello Austin. And so what's happened here is that we've turned all of the local host volumes that start with /Flocker into a global volume namespace across your entire cluster. And what actually happened under the hood there was that Flocker took a snapshot of the volume that was on host 1, replicated it over to host 2, just all in time, all before Docker got a chance to actually start the container and run the cat command, which got the data out there. And if you could use your imagination a little bit to think about what this would mean, for example, underneath Docker Swarm or underneath Fleet. What this means now is that if Fleet decides to reschedule a container on a different machine, because the configuration for which volume it's using now refers to a global volume namespace across your entire cluster, it'll just get started on a new machine, and MySQL or whatever, Postgres, or your Elasticsearch shard, or whatever it is that's running inside that container, will just start up, and it will be as if, from the Linux program inside the container's perspective, it will just be as if that got restarted, or as if the machine is running and got rebooted. So, yeah, it's portable volumes.
So because you're intercepting the request, a really simple file, what happens when you have large amounts of data? Is Docker going to blow up when it doesn't get anything back from that request, or how hard to test that?
So, yeah, so the question is about large data sets. So this is where, like, the PowerScript approach needs some more work, because what we had in Flocker, because we were controlling the command line interface, we were controlling the user experience, we were able to do what I talked about with respect to the two-phase push, where we take a snapshot of the container while it's running and shut it down, replicate it over before shutting it down, and then start it up on the other side, because we can sort of orchestrate all of that. Then when we're running it with our own tooling, we can be smarter about doing that two-phase push. Yeah, at the moment, with the current implementation I just demoed, if it's a large amount of data, it will just take a long time to start the container, because it needs to copy it across. However, we're working on multiple storage backends, and a different storage backend, like an EBS backend, would just have to unmount the volume from a VM and mount it to a different VM, and that's constant time, however big the volume is. And also, if you're plugged into any other storage array or any other storage system, then the same is true.
How far is BTRFS in your roadmap? Or are there bigger?
ClusterFS isn't on our roadmap really, because we're not convinced that it's production ready for right heavy workloads. But it's open source, so hey, you want to build a ClusterFS storage backend, then it's just implementing a few Python classes.
So you're doing all the CFS replication from the second container?
Yeah.
So what happens if the original host is just dead? So you still have access to your data.
Yeah. So that's where the alternative storage backends come in handy, because like if you're backed onto a Ceph cluster, for example, then Ceph has already done synchronous replication, it's already done Paxos with your writes to make sure that you've got the data somewhere else and it's abstracted away. But you're right, the storage backend only works for, I see there have been two big use cases for operational managed velocity containers. The first one is manual migrations. So when you intentionally want to move something from one machine to another, you want to, yeah, or you want to run it on a more powerful machine, you want to minimize the downtime, or you want to upgrade the RAM or whatever. So that's like intentional migration. And also that, and someone made an interesting point last week, that allows you to pack your machines fuller, get higher density, because when things do start getting busy, you can move them around. So if you can't move stuff around, then you have to be more conservative and overfill it. The second big use case is failover in HA. And for that, at the moment, we did actually in a previous platform in it was called Hybrid Cluster, that was a shared hosting platform based on FreeBSD-JS, which is kind of interesting. It was completely distributed. That had asynchronous CFS replication built in, and we did do failover. But because it was asynchronous, it would introduce some data loss.
Sure, but that's better.
It's better than 100% loss, but it's also difficult to make the user experience really good. And it depends on what your application is as to whether async replication is acceptable.
Sure.
So we're not going near that right now, but I'm really interested to know if people would rather have, would be happy with async replication for certain applications.
I think at minimum, snapshot can break down the logic pipeline snapshot. But even if you get this, or the snapshot and ship it, doesn't necessarily migrate the application. And it's experience that snapshot. Yes.
Yeah.
You're not guaranteed
your Cinder backend and all that kind of stuff works. You might be able to move that stuff around.
Yeah, I'm probably not the best person to talk about Cinder backend actually, because it's our dev team working on that. But I mean, basically, the way it works is that so Blocker, like what we're calling the 1.0 architecture, because we're shooting for 1.0 in the next couple of months. What we're calling the 1.0 architecture has like a separate API server that is like the source of truth. It's sort of like Flocker master. That will eventually use a consensus algorithm and distribute key value stored. So the control service itself is highly available. But anyway, so there's the API server. The user can make requests to the API server. The user, in this case, is the PowerScript Flocker plugin that's running next to each of the Docker daemons in the cluster. So that will go off and talk to the API and say, hey, I want a new volume, or hey, this volume already exists, please move it from one place to another. And then each of the nodes in the cluster have conversion stations that run on them that read from the API and then try and get the thing into the right state. And so the OpenStack Cinder implementation is just a different volumes convergence agent that still talks to the same API. So we're gonna have this. Well, we've already got a volumes API that allows you to create volumes and move them around, and that's what PowerScript Flocker uses. And the Cinder backend is just going to do this detach and attach operation and create operations based on that. So Flocker is basically bringing like multi-node volume primitives to all of the container orchestration frameworks via this integration. And then we're also having these multiple storage backends Cinder as well. Was there anything more specific?
Well, I was just interested in that because I guess looking at this one, trying to apply this to my use case is a little bit more difficult because the nodes of my infrastructure are very fluid. Like, we can move and add nodes like once an hour or whatever, like to get even more frequency. So being able to define that is difficult. And so I was looking at something that isn't. I'm not trying to downplay this because I think it's great, but isn't just replicating file systems around, right? Like it's actually moving this over here based on knowing something about my infrastructure, right? And that's what that sounds like, right?
Yeah. So are you using OpenStack, by the way?
I'm in practice, so yes.
Okay.
Kind of.
Okay. So we definitely want to support more dynamic things like that. I mean, so the example I gave here of like, to be clear, the example I gave here where you're manually specifying the hosts, that was only in the original prototype version of Flocker. And that's going away in the 1.0 architecture that we're working on. That'll be more of a dynamic. You'll have to run the API somewhere, but then you can add and remove hosts, container hosts easily, but when it's integrated into an orchestration framework, it'll kind of be the orchestration framework's job to do that, like dynamically moving things around, but we'll just make sure the volumes show up in the right place at the right time for you. So, yeah.
So in this, in your latest example, how is PowerScript integrated with Docker? Because you said that the commands are in there unmodified Docker. So how is it intercepting the requests?
So PowerScript, which is explicitly a way of prototyping Docker extensions, is a Docker API proxy. So the Docker CLI is actually talking to PowerScript. PowerScript then goes off and sends the request off to Flocker and says, hey, do you want to deal with this? For like the container create, container start commands. And Flocker's like, oh, it has a bind mount that starts with /Flocker in it. Cool, yeah, I'm going to go and do something with my volumes API. Or it says like, oh, there aren't any bind mounts, or there are unrelated bind mounts, so I'm going to ignore that request and pass it straight through. And then PowerScript passes the request off to the Docker daemon. So it's like a pre-hook.
So you would either run the PowerScript on the port that Docker would be running on and run Docker on an alternate port?
So
Or
that's
just configure Docker to talk to a different port?
that's how PowerScript works.
Yeah.
But PowerScript is not the end
It's
game.
just a prototype.
It's a prototype. But we're actually we're working closely with the Docker team on full-on Docker extensions. And that will mean that you don't have to run this like wacky API proxy on each
More
host,
middleware.
but instead that you'll be able to type Docker plugin load Flocker and Docker plugin load Weave and Docker plugin load whatever else you want.
Is that something that's in progress, or
Yeah.
is it just in talks right now?
That's it. That's in progress. We've got some prototypes. I could have shown you today. There's a prototype of Flocker that interacts with a modified Docker daemon. So the way the extensions are going to work is extensions are shipped as containers. They're privileged containers in the sense that they're special. They have a privileged communication channel to the Docker daemon. So when you load an extension or when you load a plugin into the Docker daemon, it waits for the plugin to start listening on a special port, a special socket inside the container, inside the plugin container, and then it does a handshake with it. And the handshake might allow the plugin to say, hey, I'm interested in volume events, and then Docker will send it volume events and give it a chance to intercept. So that's going to be baked fully into Docker. And that's the point at which we're going to declare this whole thing like production ready, and once we've got our OpenStack backends in the volumes API and so on. So this is really just a preview. Sorry, it's not finished yet.
No,
It's hard to now. Any other questions? So, I think you're asking about snapshots and the ability to go back to a previous snapshot of the volume. Is that?
No, I was wondering if it would recognize that that was a possibility. If you happen to be in that situation where you move back to where you were before.
If you actually move the volume from one machine to another and then back to the first machine, correct? Yeah. It ought to never get into a state where it like gives you an older version of the data than is the current basis.
I was just asking if it would like delete it or if it would see
Is it
it.
doing a delta, so it's faster?
Is it faster to move it back?
Could it be?
It could be.
That kind of
Yeah, so,
that work?
yeah, it definitely could be. Actually, I think in the current implementation it will be. So at the moment, if you move something from A to B and then you move it back to A, then it will only copy the difference on the way back as well. Yeah. But then there's a trade-off, of course, because you don't want to keep like stale copies of your data around on all of your machines. So we need to have some cleanup policy on that.
If you go from like node 1 to node 2 and node 1, well maybe they're both still good, and you bring up a node 3, does it copy it from node 2 always, or if node 2 dies, can it copy it from node 1? Will it like insist on coming from the most recent copy? And how does it know which where to bring it from when you say like /Flocker /volume 3 or whatever you have?
So the API server is like the source of truth about which machine is the current master, and it never allows multiple machines to become the current writer for the same volume. It will always, so with the ZFS backend, it will always try and push from the current master or from the current master to the machine you're pushing to. So it doesn't do anything clever like trying to pre-replicate from a different machine. We did, as I say, previous platform we built was more sophisticated and would do continuous replication to a configurable number of nodes. And in that case, like you bring up a new node, and it also did this thing called auto juggling, which was kind of fun. So like if a machine got really busy and it had too many containers on it, then it would move some of those containers onto a quieter machine. And if you introduced a new machine into the cluster, the current machines would be like, oh, hey, you're not doing any work, like have some work. And that was pretty cool. But that's an orchestration level thing, so we're not there yet with Flocker. But we'll get there. Someone check that.
Is it possible to secure the access? I mean, as general Docker volume, before it's like anybody can just, use this container if they have the volume declared on it. So with your extension, can you actually put some security measures in that? Or have you thought about it at all?
Yeah, so we take security very seriously, but we don't yet have for example, the reason the API server runs on a different physical machine is that we don't want the metadata service to be running on container hosts in case someone breaks out of the container. But we don't yet have sort of a concept of users in the API. So at the moment there's just one global API access based on TLS certificates. So yeah, we're assuming at the moment that the orchestration framework will have multi-tenancy in it from the perspective of like if it wants to map volumes onto users, then it will do that. I don't know how true that is. I'm not actually sure about the current state of user management like Kubernetes or anything like that. But yeah, so not yet. But it probably makes sense at some point to have users to map them onto whatever the orchestration framework actually uses.
Another question for everybody else. So presumably you're interested in stateful containers. So I was wondering, like, what is the biggest problem you have or that you're trying to solve in order to get stateful containers running in production? You said it's hard.
I'm very good at this. Spent Thursday with one brother at DevOps who's more familiar with it. Just trying to do the simple thing. We had an end application that required MySQL. So, okay, so pull down that thing. And then we were like, okay, well, we need to be able to persist changes in data, in case the Docker container crashes. So it just turned out to be difficult because if you go and look at MySQL on Docker Hub, it's going to assume that it's all contained internal. And so we had to do this chicken and egg thing where we needed the Docker, the environment stuff for MySQL that's inside the container. We needed that outside, existing outside of the container before we mapped it into the thing. Because basically it's already installed MySQL thing. And so it's installed and it's expecting a lot of configuration and data files to be inside the container, but we wanted to persist outside the container. So we had to do the strange thing where we brought it down, installed it, brought it up as a container, mapped that, parsing that onto the host, killed that container, brought it up again with the map volume going inside. That just seemed like a little bit too much work.
Yeah, that's pretty insane. I mean, I think that points to the fact that support for stateful containers in the ecosystem is pretty new. But there are definitely some Docker images that are better than others. And in general, the good ones just assume that like the volume is going to be mounted at /data or whatever, and they'll initialize themselves when they start up using that blank volume. And then if there's any config, then maybe it lives in the same volume, or you can find out it over the top of the file or something.
The problem is without that good curation, there's 30 Docker files.
Yeah. So something that might be useful for us to do is to actually just have a list of Docker files that, or actually even better than us doing it, if we can get a community around Docker that curates a list of good containers. People who want to build databases and service-style stuff on top of Docker.
Stateful containers.
Yeah.
Here's a badge almost.
Yes. Certified by Docker.
Yeah.
Great. That's a really good idea.
The other thing that we ran into was there are certain applications that just didn't do well when you snapshot the files and then delete them.
Yeah.
And so we had to figure out a way to LES the application so that got into a loan state like this. So just weird things like that. When things work well, they work great with snapshots. But when you actually have like real problems in production, you'll end up with like unrecoverable snapshots with data collection. And so that's one of the key things with the downfalls of these stateful containers. You have to do it in a way where you have to test the recovery in interesting ways, right? Like test it when you ran out of space. It turns out like if you run out of space on like ButterFS, you might as well fill the box.
Yeah.
Like there's all sorts of like weird things that you run into in production. And that's the part of pieces that kill you.
Yeah. You're absolutely right. I think, so on the point of the consistent snapshots, the only thing that Flocker uses snapshots for at the moment is those controlled migrations. So at the moment, it takes one snapshot while the thing's running, but it only uses that to speed up the final copy. And the final copy happens after the container's been sig-termed and has shut down cleanly. So it should be in a consistent state.
Where it works.
Yeah. And so you can test that just by moving the stuff around, because that's effectively the same as using that internal snapshot mechanism. But as soon as we introduce a feature like snapshotting for backups and shipping those backups off somewhere, then we're going to have to deal with the whole world of reassing various things in various ways. We haven't entirely figured out how to do that yet. But we have got some experience with MySQL had exactly the same problem. You had to run a flush tables with relock around the snapshot of the
That's exactly how we explain it.
So, fun games. We'll get there. And we'll hopefully have a set of recipes for the popular ones that say, yeah.
Metadata plugins or environment variable plugins for the DS command.
Yes. Okay, would you want that to be like a shell script? Or like an arbitrary execution inside the container?
I do shell script